Hi all, welcome to my YouTube channel, Know About Embedded System. So in today's video, we will understand how to interface hex keypad to the microcontroller. If you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video here, hex keypad interfacing. So this hex keypad interfacing, it is also called as a matrix keypad. It is almost the same definition. The matrix keypad, it's also called as hex keypad. So it is an input, basically it is an input device, and it is used in almost all our regular embedded systems, like in the calculator, in the security systems like ATM machines, and various industrial applications. We will use this hex keypad as an input device. Okay, and even whenever we want to implement our project prototypes, or maybe in the real-time projects also, we will use these hex keypads as an input devices. So what inputs we will give? So from this hex keypad, so you know that already. So it is possible to give possible inputs, nothing but 0 to 9 and at least A to F. It is possible to give 16 combination 0 to 9 and A to F, and it is also possible all English characters with a different presses. Like if you press 1, it is A. If you press 2, 2 times when you press it is B, kind of like that. So it is possible to display, or it is possible to take all our decimal inputs and also almost all English characters. It is possible. Okay. Now, how this interfacing is done? So in a general way we will understand. Later we will go to the program. So how the interfacing it is designed inside the hex keypad. So basically guys, you should understand one important thing. This type of hex keypad, or this type of keypads will have 4 rows and 4 columns. So here we are considering 16 keys. That is why we'll have 4 rows and 4 columns. So each row corresponds to one set of keys, and each column will correspond to one set of keys. This I'll explain later. So whenever you press the switch, let us assume, okay, here you can say I'm highlighting. Whenever you press any key, so it is going to interact between particular column and that particular row. You can see here like that. Whenever you press the switch or whenever you press the key, this is going to create a contact between one set of row and one set of column. Okay, so whenever you press, so particular row column will go high or go low. That depends upon the design. The particular row and particular column will go low or it will go high. So based on that low or high signal, we can detect the position of the key. So at this position, the key position is 1, 2, 3, third column, second row, right? So the row 2, the key I have considered here is row number 2 and column number 3. Row 2, column 3. So based on the position, we can detect which number key has been pressed, and based on that we can take an action. So this is a simplified explanation. In detail I'll explain again later. This is what I have told you. Okay, a key is going to establish a physical connection between each row and each column. Each row will have one set of keys and each column will have one set of key. Whenever you press the switch, it is going to create a contact between row and column which has been pressed. Okay, now after we have to, what is our role, embedded engineer role? So we have to detect two important things. One is a row position and column position, because we will not know which key is pressed. Trial and error method we have to check. So that is why we have classified this complete setup into two things. One is a row scan and one is a column scan. In the row scan, we need to check in which row the key has been pressed. So first of all, like we have to check in which row the key is pressed. That is the first thing, that is called as a row scan. And then we have something called as column scan. Same thing. In the column scan, we have to check in which column the key is pressed. So ultimately, so we will perform one row scan and one column scan to detect the key position, or where the key is pressed, that position we have to identify with the help of these two actions, row scan and column scan. Now, based on the row scan and column scan, or based on the row position and column position, we can decide in which row and which column the key is pressed and which the character that position is corresponds to, so that we can identify. Either it will be 0 to 9 or any special functions such as multiplication, subtraction, minus, and so on, almost all English characters. Okay, so in this way we can identify the key closure in the hex keypad. Okay, in detail we will see in this slide. Okay, so this is how internally it looks like when we give the numbering to each cross section or each interaction. Here you can see this is my row 1, row 2, row 3, row 4, column 1, column 2, column 3, and column 4, right? In the row 1, you can see example I have considered. So I already told you each row will corresponds to one set of keys, and these keys are nothing but numbers. Row 1 will corresponds to 0, 4, 8, and C. Similar to that, row 2 will corresponds to some set, and then row 3 and row 4. Similar to that, even columns also will have its own corresponding the key numbers here. Column 1 will have 0, 1, 2, 3, and then 4, 5, 6, 7, and it goes on like that. Okay, so what is our role? As I already told, we have to perform two important actions. One is called row scan and one is called as column scan. Two important things we have to do. I'll take one example and I will show you how to perform row scan and column scan. Okay, so in the top you can see I have given one table here. Table I have given. In order to perform, I will take example of a row scan. Row scan and column scan both are similar with a small change. Okay, now let us take an example of a row scan here. So whenever you want to perform a row scan, so what we have to do, so rows we have to make it as called input port. Rows we have to configure as input port, and then columns we have to configure as output port. So this configuration we have to do whenever you are performing a row scan. We have to perform rows as an input port, columns as output port. So why we have to do like this? Because I'm performing a row scan. Row scan in the sense read the row state. What do you mean by row scan? Read row state. So what do you mean by row scan? Row scan means read the row state. So whenever you are reading, we have to make that corresponding port as input port. Okay, so like that. So whenever you are performing a row scan, we have to read the status of a row. That's why I'm making rows as an input port and columns as an output port. Okay, now that's the first point. Second point, so now with respect to this table, this is very important, you need to understand. So whenever, let us assume there is no key pressed, there are 5 combinations are there. So let us assume there is no key pressed. Whenever there is no key pressed, it is going to return, your microcontroller will return the state as like this, 1 1 1 1. That means by default all port pins will be high whenever there is no signal. If there is no key pressed, it is going to return something called as 1 1 1. So this 1 1 is nothing but hexadecimal F. Similar to that, let us assume the key is pressed in the first row. Let us assume key is pressed in the first row. Whenever key is pressed in the first row, that particular row will go to 0. This particular row, I'm talking about first row, the complete row will become 0 0 0. Here also it will become 0. Here also it will become 0. And here also it will become 0. And other row number 1, row number 2, and then row number 3 and row number 4, all will be in high state. Only that particular row, whichever the key is pressed, that particular row will go high, and other rows will be in high state. Only that particular row will go to low. Okay, so in this way, like row 4 no key pressed, it is 1, row 3 no key pressed 1, row 2 no key pressed 1, and row 1 the key is pressed and complete row will become 0 0 0. So when I write it in a binary form, it will become 1 1 1 0. So now that's what you are seeing here, 1 1 1 0. Okay, and when you write it in a hexadecimal form, this is going to be 0xe. Okay, similar to that, when I write it for second row, this is for second row. So when I write it for a second row, so this corresponds to 0xd. Similar to that, when I write it for third row, and this is going to be 0xb. Similar to that, when I write it for the row number 3 or row number 4, that's going to be 7. Okay, so like this, the same thing whatever I have highlighted here, this plays very important role in designing the coding or in understanding the key closure for row and column. The same thing whatever I have written here, the same thing I have kept it in the table format. That's it, both are same. Okay, so whenever there is no key pressed, it is your row, particular row, all the rows will return 1 1 1, indicating that there is no key pressed. Okay, and let us assume the first key is pressed like this. In the first row the key is pressed, or in the first column the key is pressed, that particular row or that particular column will go to low, and other rows and other column status will become 1 1 1. And if you write it, its hexadecimal value, it is E. Similar to that, second row and second column is 0, the 1 1 0 1, that is D, and then for third row or third column 1 0 1 1, then that's going to be B, and similar to that, fourth row and fourth column is 1 1 1, and it's going to be 7. Okay, so in this pattern, in this way, the pattern will be produced whenever there is a key pressed. Way you can detect the key closure of a row and column both based on this pattern, and based on that you can take an action. So which position, which row and which column, and based on that you can take an call which number it is, in which position the key is pressed and what is that number based on this combination. So based on this position you can decide which character that particular position corresponds to. Okay, so I hope this video is clear to you. If you feel this video is an informative video, please click on like button and subscribe to my YouTube channel.